Okay, so on this question, they're asking us to express the equation in exponential form. So they're giving us this logarithm. It's, let me write it over here. Log base 2 of 8 equals 3. So notice in the logarithm that one of the numbers is lowered down, right? See how this 2 is lowered down? That's not a mistake or something. That's on purpose. They lowered down. That one's called the base because it's the bottom, right? Like the base of anything is the bottom of it. The base of a statue is the bottom of it. And so that's the base of the logarithm, the bottom part. And so what is a logarithm? Well, basically a logarithm is an inverse of an exponential. So remember, back in section 5.1, just 2 sections ago, we learned about inverse functions. I talked about an inverse toaster, which is like the opposite, right? It would turn, toast back into bread kind of thing. Well, that's what a logarithm is compared to an exponential. It's the reverse. So logarithms were made up, like all of math, just totally made up, for the purpose of being the opposite of exponentials. Now, so basically you can switch between a logarithm and an exponential. They can say the same thing, like one or uno, just 2 different languages saying the same thing. Here's how you do it. It's really simple. You grab the base and you go just like this. In fact, let me, little thing, you go right here and right there. It's kind of like the Nike swoosh symbol, right? So it becomes 2 to the 3rd power equals 8. So there it is. So that's the exponential form. Let me put a box around here. This is exponential form. And that's log form. So log form. This is exponential form. But they're saying the same thing. They have the, let me put it in these words, same meaning. Just like if I say one or uno, right? I mean the same thing. Well, those 2 expressions mean the same thing in 2 different languages. One of them in log language, one of them in exponential, meaning power, right? Exponents are powers. Exponential language. This one you're more familiar with, aren't you? 2 to the 3rd power equals 8. You're used to that one. 2 times 2 times 2 is 8, right? 2 times 2 is 4 times 2 is 8. This log one looks a little bit weird. Notice they have the same base though. See how the base and the base, meaning the base with something that has a power on it. They have the same exact base. So how do you switch between the 2 ways of saying the same thing? You grab the base, you swish over and back. So you go 2 to the 3rd power equals 8. 2 to the 3rd power equals 8. Okay, so what do they want us to do down here with this A and this B thing? Well, see what they say right here? They say they want you to write it like 2 to the A equals B. That's what they say right here. 2 to the A equals B, right? Okay, so then what's the A? 3. What's the B? 8. A3, B8. Does that make sense? They just want you to identify the pieces of the puzzle there. Let's do the next one. How about this one? So I'll bring it over here. It's log base 5 of 625 equals 4. Okay, here we go. I'm going to do the switcheroo thing. Again, what do? You grab the base, travel over here and back there like a little circle, little Nike swish thing. So it becomes 5 to the 4 equals 625. That's exponential form. We just notice how we dropped the log word when we do that. So whenever you do that swish thing, you lose the log. You drop the log because you've just changed out of log language into exponential language. Okay. And now we just, again, I'll just write 2 to the A, or not, that isn't what they wrote, my mistake. Let me try that again. It's right here, huh? 5 to the C equals D. Oops. They want me to write 5 to the C equals D. Getting a little sloppy there. Whoops, that's not what I wanted. Okay. Yeah, 5 to the C equals D. So what is C? 4. What is D? 625. So C is 4. D is 625. And there we go. So we've changed two expressions from log form to exponential form by doing the little switch thing. Log form to exponential by doing the switch. You grab the base and you do the switch. And there we go.